Hello, this is Amit. We will quickly refresh till now what exactly we learned in Hibernate. We are here in Hibernate features, and we started to learning Hibernate mapping styles, and we already learned about the simple mapping, collection mapping, and we are here exactly in inheritance mapping. So here we see that how we can map our table in table per subclass mapping by using a Hibernate core as well as by using a Hibernate annotation. And here we also learn about that how we can create a table per class mapping using a Hibernate core as well as Hibernate mapping. And now today I am going to explain about table per concurrent class mapping, and here we can understand how we can map through the annotation and utilizing a core concept. And after that we will quickly try to find out the difference, means which scenario we can use table per class mapping and where we can apply table per class mapping and concurrent class mapping concepts. And we will quickly differentiate where exactly change means. For example, right now we are using a table per class mapping and we have to convert into the table per class mapping or concurrent class mapping, then where exactly we have to change. So through that we can easily grasp all the knowledge. And so quickly we will start the concept of table per concurrent class mapping. So I little bit means I just want to explain one thing: the table per concurrent class mapping and table per subclass mapping. It's almost similar. Only one thing is there. When we will create a table per subclass mapping, means that every means subclass dependent to the main superclass. But here table per concurrent class means that superclass means concurrent class have the separate table information. We just when we will compare about that both tables, then we can exactly understand. Somewhere you find about that means table. For example, we are creating this table like a student have two concurrent class, current student and old student, and current student have regular student and weekend student. So somewhere you find about the definition when you are going to utilize a table per concurrent class. They explain about that per how many concurrent classes there, that much table is created. So it is not exactly correct. When you will see that table, you can understand about that. So either you can use subclass or either use concurrent class. Table creation is same, but when we are going to utilize that table, so we can directly utilize a current student, old student. It's not dependent to the student. All information where a student is there, so that information also available inside that current student. So dependency of a student is not there, but when we are using a subclass, that dependency is there. That field already available in the student, like for example student ID is there and a student name is there. So name no need to add here in the current student in the new column or old student in new column. When we have to fetch, they will join this table and fetch it. But here in the concurrent mapping means table per concurrent class, this thing is there. And when we are using to sub class mapping, where means name if is there, then it's not available in the current class, so we have to join it. And concurrent class, all the information, even the field what the student field is there, that will be repeat here in the current student and old student also. So we no need to join directly. That's reason it's a different definition is there in table per concurrent class. How many concurrent student is there, like a current, old, regular and weekend, that 4. It's a dependent table, and a student is not even the dependent table. It's not that much required here. So so we will start here. So first we will check that what the database we are going to utilize. So for right now we are using a MySQL, so we'll check that MySQL database. So this is the already created example Hibernate Core 5. So we'll just check it that configuration is correct or not. So what database we are going to utilize, so that database is available or not. So we are going to utilize that visual path we are going to utilize visual path directly. So we'll check that visual path is there. If already some table is created, then we will destroy that visual path database and we will recreate it. So we'll just log in MySQL, that MySQL console. And just show database. Yeah, so visual path already there, so we'll drop it. Just drop visual path, drop database. So it is drop, so we have to create again. So create, drop is there, just we have to change create database. So now we have a visual path, so we'll just use it. So use visual path. So now database change. So now it's newly created, so nothing is there, so empty set. So when we will create and then after we will find out means how many table is created here. So again going to explain about when we are going to utilize a Hibernate core information, that code started with this configuration. Even we are going to utilize Hibernate annotation or core. First point to check is there in cfg.xml. CFG means configuration and hibernate.cfg.xml. So this is the main point where we have to configure. What configuration be required? That session factory configuration is required. What is a session factory? Session factory, it have a information related to one database. So for example, I already explained about that. If we have a requirement to connect multiple database, like a two database kind of thing, then we have to create a two session factory object. So one session factory object have a information related to one particular database. So if we going to connect through database connection, then we have to write this kind of property. So property, what basically we have to add driver class. So driver class com.mysql.jdbc driver. So this is a MySQL driver that we have to register here. After that URL, that what the database using and where it is exactly running. So my database is running localhost and I am using a 3307, that is a by default port of MySQL I am using, and this is a database name. What the database name? That we already created here. This visual path drop, already drop on visual path and we created database visual path, and now we are going to utilize. So here are this database, MySQL database have a many databases. So this databases like visual path 1 2 3. So which visual path we are going to utilize, where our table is created and where our information will be stored, that will be point out by this after this slash visual path. And here we have to provide root as a username and password. If we don't want to provide here like that user ID and password is highly secure thing, so we can see that in the next lab next program how we can shift this user ID and password to programming way and how we'll encrypt it. So right now we just try to understand the inheritance mapping concept, so no longer requirement of means we can directly add here. And after that this dilate kind of thing means if we are going to utilize a SQL kind of thing, any query language, object oriented query language, then particular query will be generated. So what query you want to generate? So we are using a Hibernate with MySQL, so we want MySQL query. For example, our Oracle query is different, MySQL query is different. So when we are going to write a object oriented query language like from a student S, so the particular query we have to create when we are dealing with MySQL database. So this type means that will be point out means Hibernate runtime system will be point out to, when we are going to generate SQL, it will be a dilate type SQL generation. So dilate is a MySQL dilate, means we have to generate MySQL here. So after that we have to show SQL, means we already explained about that, what the query we will run and what the internally query will be generated, that we want to see here in the side the console. So through that we can check that if query is generated or not. After that, this auto means we are going to create hbm2ddl.auto creation. We are not explicitly going to write any SQL to create a MySQL table kind of thing. So here we can directly provide this creation, means Hibernate runtime system is responsible to create dependency tables and its information inside the database, and we have to complete ready to utilize table and we can utilize it. And after that, resource mapping we have to add here, mapping resource, and this is a resource like this file resource we will provide whenever we going to utilize a Hibernate core. File resource we will provide whenever we going to utilize a Hibernate core. Whenever we want to mapping in somewhere in XML file, then we have to point out that particular XML file. So we are going to map this all information under the student.hbm.xml file. So we just add here. So same thing here, if we want annotation type, so we have to replace this resource with class. So we have to write here class, and we have to provide class related path like a package and class name without extension of .java, like that. Here resource means a file system, so we have to provide complete classified path of particular resource, HBM resource. So that thing. So after that, just a session factory. So one session factory is over. For example, we have to create a multiple session factory, so we have to create the same information here like a session factory. Again, that session factory will be start and session factory will be end. And we have to provide all information here. We will check that to database connectivity code also, or we can provide a two different hibernate.cfg.xml file, and we will point out to different file whenever we going to initialize it. That time we can point out to different file, and there two different file will be responsible to generate when we create a Hibernate like that. When we are going to create this configuration equal to new configuration, we have to pass here the particular specified path. So we are going to create some path, file system, and we just have to create a two Hibernate like oracle.cfg.xml, Hibernate mysql.cfg.xml. I will show you that. And after that, mapping concept, once we understand the simple mapping concept fully, after that collection mapping we already understand, simple mapping we already understand, inheritance mapping, the two concept we already understand. Now we are in the third concept, and next we will go to the association mapping like one to one, one to many, many to many, with unidirection and bidirection code. And once this mapping is done, I will show you that how we can map multiple database inside the single code. Means I just want to store the single data, I will just create one SQL, and through that we can fetch with the multiple database, and we can store the information in the multiple database. So only one query is responsible to store the data inside the MySQL, fetch the data inside the MySQL, store the data in Oracle, and fetch the data from Oracle. Like that we will check it. So now we are on this third concept of Hibernate, table inheritance mapping. That is a concept, table per concurrent class mapping. Here per concurrent class table is created, and that is our data going to store inside that concurrent table information. So here we already explained about that. After that we'll see that mapping. So mapping is completely individual here, where we see that join column, or like a table per class or table per subclass. There we have to map like that. Inheritance mapping is there, like two child is there, then we have to map inside that super child all the two child is there, but here what we have to do, all are the individual information, that is not even the related. Like this is the same thing, Hibernate mapping. We will start here. After that we will provide a package information where all our Pojo classes or entity classes is available. After that class, here name that class, what the class is there. A student is the super class of all inheritance type, like that. Students is here. After that current, old student, regular student, weekend student. So we will configure like same thing here. So we'll add a student here. So table name, when it will be created, it's my student C, or just we will create a student C. A student C means when we want to convert same code into the annotation, that time we will add the table name is Hibernate, means a student A. Now it is a student C. So after that we added ID, name, SID, column, SID, type int. That is the same thing what we are using inside the property. So only we are going to generate a primary key, so we have to add ID. So this and this part, this attribute is responsible to generate a primary key. Inside that we have to put generator, that we have to add that class. So inside the ID generator class type means which algorithm we want to generate a ID. So we have to multiple algorithm to generate a primary key, but right now we are not working on to primary key generation algorithm. We try to understand here the concept of inheritance. So we will not change anything, we just use the old increment type only. So we are going to utilize a primary key generation generator algorithm increment. But I just want to add here, we have a multiple primary key generation algorithm. We will check that in the next lab, and even if that algorithm is not sufficient, we want to generate some our own primary key type, like that. So our company start with our company name underscore, and that will be increment 1 2 3, or some time stamp. They will utilize IP address, current running machine, and what is the time. They will convert some timing hexadecimal or any kind of logic. We want to generate this kind of unique code, then we can utilize that. Also we will write that algorithm, we will register, we will see that how we can write our own primary key generation algorithm. After that properties here, name, name, CT, status and toll free, that is all total fee, that is all related to student information. That is what the information here, properties here we just added under the student mapping, under the this student. After that the next is a current student. So next is a current student, so we have to map the current student. So current student, what the field is there, so just check. So current student have this 3 field, but we added some more field here. So current student have only this 3 field, but we added as name, CT, status and toll free. That only I want to explain about that. So whenever subclass mapping we are using, that thing already available in the table of our super class, we no need to map here. But when we are using a per concurrent class, means all the table have enough information, no need to go to this super class. So what the field is there, it will be stored here also as name, CT, status, total fee, balance, timing as kind. So like that foreign key concept, or when we are going to join concept table or something where we have to all information, like we want to whose fee balance is something, then what is the name of that? When we are using table per subclass, we have to take this information in this table, and as name or name we have to take from the student table. But here we added all field inside that single table, and you just see that here we have the class subclass like different thing, but we directly added class here, class name and table name. Just added C means current student, and here C means core. So this is just a name that going to create a table there. So again this generation what we added here, we have to add exactly same. So how many field is there in the particular student, like that we are mapping in the current student. Just go, we will go again and check that. Yeah, so current student we have only 3 field, and after that we are calling this 3 as name, city, status and total fee in the super class. So we have to map this super class information as well as is our class information inside that HBM file. So that we already added in property, but in subclass concept that is a not we cannot, means we don't need to add this thing. So when we are going to utilize a subclass, one difference is there, that will be utilize less space, means here we have to duplicate information, like that student s name is there, also s name is here, so here extra column is there, but when we are using a per subclass, then we have the we have we just save few columns. So that is a one difference, that more memory conscious thing, when we are going to utilize we will prefer subclass. But just think about that, when we are going to fetch some information we have to contact with two table. For example, we want some branch name or something, status of the particular student that is not available in the subclass, then we have to go to the superclass and fetch the particular information, then we have to join this thing. So whenever the means we have to frequently passing a query, and that will take too much time, we want some more performance kind of thing, then we will utilize this kind of mapping. So again, the depend to the situation, in which situation our mapping is fit, we have to create particular type of mapping. So again we have the regular student, same kind of thing. Regular student, if we check, so regular student have 3 field, but here it is a calling 1 2 3 4 5 6 7 field again. So 7 and 3 10 field. So we just mapped all the field here. So 1 2 3 4 5 6 7 8 9 10 field we mapped here. So when we are going to utilize a table per concurrent class, the straightforward thing is there, we have to register all the classes with ID generation algorithm. What we are writing for the one table, we have to write same thing for all the table. It's not anything here, it's different. So we will start with the class, we will add the particular name like a regular table, a student table, old table. After that we will add the table name where we want to store the particular data, and after we have to add primary key ID generation algorithm, and after that we will map all the property like a name, s name, city, status, toll fee, fee balance, timing, branch, qualification, percentage, year of passing. We will add in the single place, and we will repeat until our complete table is not completed. So this one is for weekend student, this is for old student, like that we will map. So here we see that, so this classes is started here and end here, so it's not even related to any class, all class are individually registered here. So when we are going to register individually, then we'll say that this is a table per concurrent class. Per concurrent one table is created, and their table have enough information, we no need to forward any join kind of thing, we no need to contact any other table. When we want, complete information is available the single table. It is using a more space because it have created all the new columns, and it will not have inheritance mapping kind of thing inside the MySQL. That individual table is responsible to individual classes, but it is a fast because when we will pass the query or kind of thing, it is not really do the join operation because all information in the single place. So this is the mapping. I already discussed about the configuration. We have to configuration through that Hibernate cfg.xml. After that we have to map like that. Here this is a individual configuration is there, where all the classes after that Hibernate mapping will repeat like that class name student table until it will be not finished, and inside that all the property we have to register. In between that we have to provide particular class name and where you want to store the table name. In between of that you have to register your primary key generation algorithm. Start with ID, name, something, what the column if you want, so column name, and type equal to int. So and generation algorithm, this is responsible to this field. So here a student have id, so we just provide so like this is a student and sid, so we will provide just this sid. This sid is a column name. When table is created, the name of the sid where we are going to enforce the information related sid, and this is a type of int. When we will create a column sid, this is a add information related to integer, and this is a primary key automatic generation algorithm. That name is, that class name is increment. So already registered class is there, we can directly utilize here. So now it is finished mapping. So we will start with the student. We already know what we are doing. We have to add here field. We just add the one default constructor after the parameterized constructor. If we want, we will add the getter setter method. I want to see that particular object what is storing, so inside the console or kind of thing, then we will utilize a toString method. When we are going to print inside the console, then the particular object will be called toString method, and we will see it what is the info value of sid, sname, ct, status and all things. So the next after this student we have current class, current student. So current student is this current student class. So current student have three field, and other field they will utilize a super, and sname, ct, status and toll free it will take from a student, and it will be initialized through that parameterized constructor. Here default constructor is not there. Sometime when we are Hibernate runtime system will be throw exception when it will be instantiated. We want to instantiate kind of thing, then it will be basically using a default constructor. And we know the concept of core Java, JVM automatically put one default constructor, either we will write or not. But when we will provide a default constructor, then JVM cannot put a forcefully one default constructor. So if we want this kind of thing, we have to add our default constructor there. So this is a current student, this is a constructor we just add here. Anyhow, this is optional now, it will not create any problem, either you will create or not. So this is a current student, and current student have two subclass, regular student and big end student. So we'll see that regular student and big end student what the information is storing. So regular student have three extra field, qualification, percentage and year of passing, and super class have 1 2 3 4 5 6 7 extra field. So it will be take from current student this 7 field. Maybe that some field is not available in the current student, like as name, that is available in the super class. So it will be it is like a chaining of constructor. So even 3 field is only there, then it will be again contact super dot sname, ct and status and total fee. That information is available student class. So regular class have 3 field, direct 3 field, and 1 2 3 4 5 6 7 extra field in the super class. So it will be total 10 field is there. So we'll initialize like that. And regular student and weekend student. So weekend student again have 3 field and 1 2 3 4 5 6 7 the super class field. So total 10 field is there. The same thing setter, getter, and if you want we can add the default constructor, otherwise it's fine. Other is there here, old student. So this is a old student. So old student super type is directly a student. So old student have 3 field, and it will be take the super field, super class 4 field, means total 7 field is there. The same thing we have to register here. How many field is there, we will register here. So like that old student have 7 field, so it will register 7 property, 1 2 3 4 5 6 7 here. So it is all individual register, individual table, no mapping concept. mapping concept only inside the core Java classes. Here the individual table will be responsible to store the individual classes. Like we want to store a regular class information inside the some tables, then we create a student table and we will store there. They're all even start with the S name kind of thing, and all information will be available the single table, no join, nothing required here. Directly we can fetch inside the single table. So now we will come to the lab information. So we know that we have to get the session factory, and session factory we already created one C Hibernate util where we created a session factory through a static block. Means we want a single one time initialization, and when the class will be load, that time that object will be created, that is aggressive initialization, and after that whenever we want we can utilize this static method, through that we can directly get it. So here in the lab we are getting through C Hibernate util session factory, C Hibernate util dot get session factory. That factory method is returning a session factory object after we are using a session. So we can create a session utilizing asap dot open session. After that we have a transaction. Here transaction we will start with session dot begin transaction. I created transaction here reference variable transaction outside the try, because sometime we want utilize inside the catch if it will throw some exception and transaction already there, means that we save some data and some half of data only save, then we want to roll back. If we not completely successful or it is a partial successful, then we will want to roll back, then we can utilize a tx dot rollback. But when we will create here inside the try, then we cannot utilize outside the try block, because it will be a local variable, so it will create a problem here. So it's through transaction cannot be resolved to a variable, because whenever we create any local variable, that will be accessible inside that only, we cannot utilize outside that. So because of that only I created inside that out of try before just a try, and we will just roll back here. We'll check just if transaction is not equal to, then roll back. And we just created all the student information, like this is a student, this is a current student, old student, regular student, and weekend student, and after that session dot save and transaction dot commit and session dot close. Once transaction complete, just we create destroy that session, so session is closed. So that just information is there, and we are going to store inside that visual path, and we see that now we have the visual path here, but we don't have any table. We'll run it and check that any table is created and what happening. So we'll run this lab 8 because it have a main method. So we can directly right click and run as a Java application. Just save it, and we'll see that this taking some time because few table have to create and insert the data. So yes, table is created, and we see that they fire some query related to MySQL, like insert into a student C, C student C, O student C, or student C, W student C. And here they created a means what we are writing inside that Java file, that system.out.println is there, that query is there, and they are inserting that information. And we'll see that we'll check any table or something is created here. So yeah, we see that 5 table is created, but somewhere means if you find out what is exact different between a inheritance type subclass and per concurrent class, then we will find out that they will explain about if we are going to utilize a per concurrent class, then how many concurrent class is there, that much table is created. But it's not like that. Here all table are individual and that not have any relationship, and when per concurrent class one table is created and there all the information is available. So we'll see that what is exactly difference between this per subclass and per concurrent class, because it will be if we not find out any difference here, then it will create a problem to us. So just check that, select star from student C, C. So student C table is created where SID, SNAME, CT, status and total fee available, and we will check that next table. Next is a current, so we'll check that current student means C student C, student C. So here again see SID, SNAME, CT, status. SID, SNAME, CT, status is available. After the total fee also, the new 3 like a fee, balance, timing and branch, that is added here. So means even if we want some information like the name Sumit and what is branch name, the Sumit where he is a study, so we can find out here Sumit whose name, whose SID is 1 and his branch is OMR. So we can find out like that. But when we are using a table per subclass, that thing will not available here. Only this new thing like a fee, balance, timing and branch is available, and that map with this SID. So we'll find out like name is Amit, whose name is SID. What is the means here, if we want the person who is studying OMR, whose SID is 1, what is his name, then we have to contact this class. So we have to fetch this table student C here, but here in this condition no, but here that extra this information, the duplicate information be added here, new column be created, that is not required. And after C student have 2 child, regular student and weekend student. So regular student SID, SNAME, CT, the 10 field is there, and weekend student also 10 field is there. And we have one old student, this old student. So old student have name, SID, CT, status, total fee, company, email and CTC. This 7 field we check that we already here. So exact what the difference between there, we just find out. I have one difference here. So table per class we understand, table per subclass we understand, table per concurrent class we understand. So here no table created for classes individual in hierarchy. So per only one table per class is created. Here table per subclass, that will mean how many classes is there, that much created, and here also table for each classes is created. So both are the same, only the thing is there when we are using a subclass information, that how we are mapping inside the class, like a super thing we are pointing, what we will provide the super kind of thing, that information is not available inside that table, and only what we are going to initialize, that is available in super table per subclass. But table per concurrent class, it's not like that, that is an individual table, no join operation is required. We'll see it once again, and this is a done. So we'll see again, we just need to understand the mapping, other thing is exactly same, what we are doing a different mapping strategy. So I just going to explain one more time. Here under the Hibernate mapping, same kind of thing, when we will start with the class, we'll provide a table name, and after that we will add all the property, even the super property also. So again it not have any relationship like that, we have the subclass or per class. Here we have to individually add all the tables, like a current student we will add individually, and how many field is there will add here, even we can include all the super field also. So after that class we have to add all the generation algorithm, means ID automatically generated, so no any relationship between the particular classes. So all the information we will available in the particular regular student itself, and it is closed here. Again its class will be start here, and weekend student information is here, and it will be close here. Like that we will map other information, other code exactly same what we are using in other inheritance class. You can once you will write one code, you can copy paste all the code in the same thing, only you have to change this mapping concept as well as this Hibernate configuration .xml. The two file only change, after that it will work. So that is it done. So we know how we can utilize table per concurrent class using a core mapping, and we will find out how we can map with annotation version. So now we will check the same concept, how we will convert this code mapping to annotation mapping. So I already created one project, I don't want to waste your time. So Hibernate annotation 5 I created. The same concept we are going to map here. What the concept here, we are utilizing a student that have two subclass, two concurrent subclass, like a current student as well as a regular student. So concurrent student and means current student and old student. Current student have two subclass, a regular student and beginner student, but old student not have anything. So total 5 classes is there. A student is a super class that have immediate two subclasses, current student and old student. Current student have two subclasses, regular student and weekend student. Old student not have any concurrent classes. So total 5 classes is there. We want to annotate, we want to store that inheritance information inside that MySQL database utilizing a Hibernate annotation mapping type. We already see that how we can map through that core, and here we are going to utilize a annotation information. So here what we are going to do, we'll just check that first. Even we are going to utilize any mapping concept or any Hibernate related project, we first check that what is the Hibernate configuration.xml file is there. So by default hibernate.cfg.xml file is there. So if we want to change this name, we have to provide, whenever we going to utilize this a configuration equal to new annotation configuration or configuration, we have to pass that particular file name. When we will utilize, means we are not passing any file name here, means it will be by default it will take hibernate.cfg.xml file. So we have to create hibernate.cfg.xml file, and hibernate.cfg file have the information related to session factory. So one session factory is responsible for one database. If we have to want to create a two database connectivity, we have to create a two session factory object. If we want to create a multiple database connectivity, we have to create a multiple session factory, means per one database information we have to create one session factory. So when we are going to configure, it will must be start with Hibernate configuration tag, after that session factory, because this information related to session factory. After that we have to register driver class, URL, username and password. That I already discussed about that, what the thing is here and why we are registering here. After that we want to we have to add the dialect, means when we are going to utilize some particular DB related query or anything, that will be some relative part automatically generated by Hibernate runtime system. So we have to provide what query you want to generate and what kind of database you are going to utilize. So we have to provide your dialect, we are going to utilize a MySQL, and please, if something, some SQL or some kind of query is there, please generate a particular MySQL query, and after that so SQL be added, because we want to see that our query generation inside that console. Like that here this query is generated. If we not add this true part, then it will be not generate. I will show you that when we will run this code, we will be adding a true and we will delete it true. And after that create, means we are not going to create this table like a student C, C student, O student, R student and W student. We are not going to here in MySQL console, or we are not going to a specific write that create table some C student something, and after that we will push that data. So this part will be automatically created by Hibernate runtime system. So we just specify here hbm2ddl.auto and create here created, And this is the main thing, whenever we utilize this core file, check here, so we have a resource, so this resource have only file student.hbm.xml, but here what is the different, here we have to map all the 5 classes, because we are going to utilize the 5 mapping classes: a student, current student, old student, regular student, weekend student. So we have to add all mapping class, the particular student name and particular class name, and we have to map like that. Even if we are going to utilize a 10 different mapping tables, so we have to add all the 10 mapping table here. So only one difference is here, when we are going to utilize a core, we have to specify only single file where all the mapping related information is available. But when we are going to utilize a annotation, we have to add all the mapping classes, because all entity classes are different, so we have to add all the mapping classes. And when we are going to utilize a core, we have to add here resource and provide complete specified path, classified path of particular HBM file. But here we have to add class, and we have to specify all the particular, like com.visualpath.hibernate. com.visualpath.hibernate is a package, com.visualpath.hibernate, and after that particular name like a student.java. Same thing here, com.visualpath.hibernate current student, com.visualpath.hibernate.old student, com.visualpath.hibernate.regular student, and com.visualpath.hibernate.weekend student. So we have to add here. After that, session factory closed and Hibernate configuration closed. Now we see that before of that, hibernate.cfg.xml, we have a student.hbm.xml, but here in this condition we don't have a student.hbm.xml, because we are going to utilize a annotation mapping concept, and we have to map. Again, just remember about this mapping concept. So top class is super class is student, they have 2 concurrent immediate 2 subclasses there, current and old student. Old student not have any subclass, but current student have 2 subclass, regular and weekend student. So we will map like that only. So we have the student, first we will point is a student, so here we have to add. So we know that we have, when we are going to create any entity class, we just make it @entity, means Hibernate will run. This is a entity classes, mapping information available here. And after that we have to add table, because we want to create a table of this particular class. So this table name I just added my student 1, just delete it, and students A means annotation. Before in core we created student C, means that table is information related to core, and now we are, what table we are going to create, that will be store the information related to what we mapped through the annotation. So after that, this line we always use, even if we are using a table per concurrent class, table per class, or table per subclass, everywhere we are adding @inheritance. So this is a standard. When we are going to utilize any mapping, we have to add @inheritance, after that strategy. So inheritance type. So inheritance type, here we are using a table per class. So table per class one table will be created. So here just check that 3 is there. We already know what is a join type, that is using a table per subclass. After that single table, that is a table per class, and now we are going to utilize third concept, that is a table per class, means table per concurrent class. Per concurrent class table will be created. And after that same thing, id generation, we will add @id, and column sid, and we will add there. So we no need to do anything. So this will be automatically id will be take care about id generation thing. So after the student have 2 immediate subclasses, that is a regular student and old student. So we'll check that what the inside regular student is there. So again we will add @entity, and after that table. So table, again we will provide our students, regular student A, that is a annotation, and after that same thing we provided here, and regular student and old student. So again we add here. So only one thing is extra in top table, that inheritance strategy, inheritance type dot table per subclass. After that same, but here you see that here we are adding ID generation algorithm, but we are not adding any ID generation algorithm to anywhere like a column. We are not adding here, but when we are map it with core, we will always use this ID in everywhere. Even this student class ID is here, that subclass current student ID is here, but we are not going to utilize the same thing here in a student. Yeah, ID is here, but regular student no ID. So it's okay, it's fine. It will be Hibernate runtime system will be manage this kind of thing, and it will be generate particular table according of that. So the next is a old student, that @ entity and @ table, and our student A, it's created. A Hibernate dot util. Before of that, we are creating a configuration CFG equal to new configuration. Here we just create a annotation configuration AFG equal to new annotation configuration. What is the annotation configuration? Here annotation configuration is a class available in org.hibernate.cfg.annotation configuration, and it is the same thing like a configuration object. Here two things we are doing this class by calling a configure with parameter and without parameter. If we call without parameter, means it will be used by default Hibernate configuration .xml file, and if we pass with the parameter, means what the file you will pass, it will be you take that file as a configuration document. We are not passing here any parameter, means it will be take a hibernate.cfg.xml file automatically, and after that we are creating a session factory through calling a build session factory method. That is nothing change here, only when we are going to utilize a annotation, that separate class is there, because the reading of the particular configuration file it's different. Annotation registration and configuration is different, so two different classes is there who is responsible to create a session factory object, and session factory have particular database related information. So and this factory method will be return particular session factory. So just check here through directly a Hibernate util we are getting a get session factory. After we are creating a session dot is asf dot open session. Asf is a reference variable of session factory, and here we are creating a transaction like a session dot begin transaction. After that we'll create all the information like a student equal to new student. So 4 parameter is there, we will pass that 4 parameter and we create this student. After that we just session dot save, and we'll check that what the int value is coming here. And the same thing with current student have some more field, so we'll store that more field here and just create this information and session dot save again, and we'll check that what is the return type of this after session dot save. The next thing is old student again have all the parameterized constructor. Through that we created a old student, and old student we added here session dot save, and this return type is integer. We'll just check that what the integer is return type is there. And the next is the regular student, so we will create a regular student object here through that parameterized constructor, and we will call session dot save, pass that particular object here. After that we'll create for weekend student, and weekend student will create like that same thing, and we'll call that default constructor and we'll pass all the value, and we will call that session dot save method, and we'll pass this information here. And after tx.commit and session dot close, means session one time duration where user can do multiple tasks. So we are doing that task, storing the information there. Once task is closed, we have to just close that session. That is a good programming habit. So even we are utilizing any resource, end of that program we ensure that we are closing that resources. Otherwise it will be create a problem to another part of this code. Sometime that resources is not available, or maybe sometime that many resources is created and we are not closing it. So it will be take a more memory, and it will be effect to our program. So whenever we are utilizing any resource, we just try if resource not going to utilize in next level, and then we just close it. And For example, if something is happened between of that, then it will come on the cache, so it will throw some exception. In this case, we just check that if transaction is happened or not, means our data is saved in the database or not. If partially saved, then we just roll back, or we don't want to roll back like that. Okay, partial save is also okay, then it's fine. Other, if we want to complete save, either we don't want to save anything, and if partially save, some table is created and name, some name is comes, but it not have a branches kind of thing, or maybe some we want to store a 50 name and only 5 name is stored there and 45 is stored not stored there, and this condition if we want to roll back the information, then we just call transaction dot rollback. So before of that, we just checking that transaction is null or not. So done, this is a done, and we added same database, yeah, visual path, and check that what is the table here. Yes, so 5 table is there. Before of that, C customer, C for core, and O student C, R student C, S student C, and W student C. This time that many table is created, but that is end with A, like a C customer A, O student C A, R student A, S student A, and W student A. This kind of table is created. So we just run this program and check that, and what is exactly effort where we have to change, we'll see it. Old student will create a same old student here. Okay, now we'll run it. So S student A, C student A, O student A, R student A, and W student A is created. We'll check it again. Yes, so C is separate, A is separate, it's created. So now we are dealing with A annotation, so we'll check that A related table. So select star from student C. Now we'll check that student A. See, yes, student A is there. Now what is before C student? Yeah, the same thing is maybe through the initialization we are using a different name kind of thing, then it information is same, but table structure is already exactly same. So after that student, we will just use C student A. Yes, it is there. It have SID, CT, S name, status, total fee, branch, and fee balance and timing. And after that, C student, regular student, and weekend student. So weekend student have SID, CT, S name, status, total fee, branch, fee balance, timing, C mail, company, CTC kind of thing. And student, now weekend student A, weekend student is done, weekend regular is done, no, regular student A, regular student, and old student O. So all the student have 7 field: SID, SNAME, status, total fee, CMail and company CTC. So exactly same, we just have to change that configuration. Here we are utilizing an annotation configuration that we have to add inside that particular class itself, and we have to add mapping here, that before that we are using a resource, we have to map their mapping class kind of thing. All the entity classes we have to add here, that with complete classified path, and after that we utilize through that annotation, we have to add the table related information and what the strategy they are going to utilize. So here they are going to utilize this strategy. One thing I just want to understand here, exact what the difference when their table is created with like a joint table and with concurrent class. So here what database it is using? It's using a visual path. Okay, it's fine. So we will check with two table and we just understand. So here table name is student A, we just create, this is a joined. So A I will add here before of that student, joined student A, joined student A table name is there, and one regular student or something we try to understand. So here again we will add regular joint RS student A. We'll run it. Okay, table is created. We check here. Yeah, so that table is created, and we just check that what is exact difference between join means table per subclass and table per concurrent class. So we'll use first the top table student. So select star from students A, students A. Okay, so it have CID, SID, CT, SNAME, status and toll free. What is in the joint student A? Student A. So see here CT, SNAME, status and total fee, and it have all the information, all the tables even, but field are same. So what is student? Regular student A. So regular student joint have SID, percentage, qualification and year of passing, but what is under the C? That is only difference. So super class no have any different, but subclass, what I explain about that, when we are going to utilize a table per subclass here that have a dependency like that 4, select star from, when we type this table information, that SID is 4 and it is mapped with this SID 4. So if we want some information like the person whose name is like this 4, whose name is Mukesh, I want to year of passing. So here year of passing is there in this table, but his name and all information is here. So if we know the year of passing the student, if we want to collect the information, so we have to contact this two table. But here in the concurrent class, all the information available in the single table, so we no need to map like a joining concept or kind of thing. But here if you see that Here extra column is not required, code duplication is not there, but here code duplication kind of thing is present. So more memory efficient if we want to work, then table per subclass is fine. If we want fast execution, then concurrent class is fine. So just point out what the exact difference. So exact difference we will find out, but just again think about that, what is the mapping type. So a student have two subclass, current and old student, and again current student have regular and weekend student. So this is a mapping concept, and we just find out what the exactly difference. So table per subclass, table per class, and table per concurrent class, three mapping is there. What the exact difference is there. So I just added few information here, like table per class, table per subclass, and table per concurrent class. Table per subclass means per subclass we see just now. Before of that we see that table per subclass and table per concurrent class. Only confusion between these two classes. This is means the single table is created and no need to create a multiple table. And we already explained about this thing. No table created for class involved in hierarchy. Only one table is created for all the classes. Only one table for each classes is created. So extra field key here added. Here one discriminator is added. Here foreign key mentioned between the tables, and this one for here, table per classes, table per subclasses. Just a minute. This is for here. Okay, just think this is the field and this is a here shifted here. So only one table means this table per class, only one, or just I will arrange it because it will be create a problem. That's less under. Yes, so now it is arranged. So this information related to table per class, table per subclass, and table per concurrent class that we see just now. So table creation, only one table is created for all the classes. Table per class, table per subclass means, and table per concurrent class, just I explain about that. Table is created same, but that here concurrent class information means all the field must be stored in the single table, so no need to join kind of thing, and foreign key kind of thing is not required here because we not going to connect between a two table. But here foreign key mention between the table will must be required, here not required. And here one extra field will added, that a discriminator, through that because all the subclasses information is stored in the single, like a student, current, old, and regular in the single field. So we how will know that this information related to current student, old student kind of thing. So if you create one new column, that name will be discriminator or something, and after that we will point out some naming conventions like a current student, old student. Through that we can find out, oh, this information is related to old student, this is a regular student, and this is a current student. So discriminator column is added. One extra thing is there. Here superclass cannot be a abstract interface. Here superclass cannot be abstract or interface, but here it will be a abstract or anything interface. It will be fine because we are not going to utilize a superclass concept. Even we are not longer utilizing that superclass like a student something. But here we all the information will be stored inside the superclass itself, and where we are fetching like that. For example, in this this here, so SID, CT, SNAME, status already available here. SIT percentage, qualification, year of passing, already here this thing is available. So we no need to utilize this student table. So all the information is available itself in the subclass. So even it is an interface or abstract class, we not worry about that. So that thing only is telling here. In this table per concurrent class, even the superclass, main superclass, that starting with this like a student. So even if it is a abstract or abstract class or interface will not worry about this thing. So we can do here what we are doing when we are using mapping, we will map with the subclass. Here join subclass, and here union subclass or class. Directly we will add through the class. We check that now, like that class information directly we will map it. And here inheritance type joint, inheritance type single table, and inheritance type table per class, this thing like joint. So three thing is here according of the joint, single table, table per class. That's three thing we can map here. So either joint table, either single table, either table per class. Joint table we are using a table per class, single table for table per subclass, and this is again not correct. Single table means table per class. Here will come here and it will go here, joint. Correct, now it is correct. Single table, join, and table per class we will use. So it is have a good support, it have a little bit poor support, and it is also poor support because this have the single table and some column subclasses will be null. Yeah, because that information is not available. Many cell will be null here because some subclasses will be not matched, like that regular student have different thing, old student have CTC, regular student maybe not a CTC kind of thing. They not working till now, so they not have a salary, but regular student, but weekend student may have the salary, so that field will be empty here. And it's not null, it's also not null. We are going to utilize a full thing. So this is a just difference between that. Just try to create all the tables different way and find out the table. Go to the inside the table and try to find out the difference. You can inherit a different type of inheritance also, like that thing example of employee, current employee, regular employee, old employee, or any kind of thing, like create a car class, running car class, expired car class, or 2018 car, 2019 car, like that. You just create any inheritance mapping kind of thing. Try to write code more and more and try to run it and try to find out what is difference is there, and then just understand in which scenario we can utilize, which situation we can utilize which class, where we will create means where we will save the more memory, and sometime if we want highly performance code, then which thing will be utilized. So according of that, just if you write more code, then you easily understand. One thing I just want to show with you, that is, yeah, I just promised before of that I show you that this true concept. So just run this classes right now once more time. So I just run this classes Java application. Yeah, we see that not int value, this is a related to this int value. So we'll just hide that all SOP kind of thing here. Just we will, then we can easily understand this thing. If one SOP will come, then create a more. Yeah, so we'll run this code one more time. One more SOP here. One more time we will run. So now it is just all the query what they are doing, like insert into the join table A, and they are passing this field, and after that they are passing a value. So I just want to show you that this here that information is coming because of property name SQL. So even you can delete it or just add false there and run the same code again. Yeah, see that execution is done and will not see anything console. So what the query information is there, what the query or something is created, so will not see here. So by default value is false. Either you will register false or not, it's not a matter. Whenever you register true, then only it will be show here inside that console. So we'll run again Java application, and you will see that this is execution is going on, means red color is here. Yeah, so execution is done, we not see anything. And whenever we change this true to false to true, means we are want to show our SQL inside the console. Sorry. So just a true, add and run this program once again. Now we are able to see that. So this field is related to, if we want to show, we want to see that SQL generation inside that console, then we just add hbm2 ddl.auto.create. So just we'll check that where right now and what we understand. So we already understand that mapping related simple mapping, like any kind of thing like an integer string thing, and after that we learn about collection mapping, where we see that list, set, bag, map kind of mapping with the annotation, without annotation, directly mapping with XML file. After that inheritance mapping, we see that three kind: table per subclass mapping, table per class mapping, and table per concurrent class mapping. And next is the association mapping. So here three mapping is there: one-to-one mapping. For example, one student have two mobile number, or then one student have two mobile number, means one to many. One student have two mobile number. For example, one student have one roll number, so one student have only one roll number, means one to one. And if many, one student have many car, means one to many. Or something is bidirectionally, means both side is many. This type of relationship come under that association mapping, and we will see that in next video, means how we can map association mapping through one to one, one to many, many to many. And what is the direction here, means unidirection and bidirection, what is that? So only one thing is pending here in the Hibernate mapping. After that mapping, we will try to create one structure utilizing a complete design pattern and high quality, like we will use a data access object, transfer object kind of thing, and we will try to create one basic Hibernate example. So till now I just try to understand that simple mapping concept, collection mapping concept, as well inheritance mapping, table per subclass mapping, table per class mapping, and table per concurrent mapping. Try to create multiple tables, try to create a multiple different example, then you can easily understand. And after the creation table, just compare between them and check that which table can save multiple memory, and which table is, when we are executing, that will provide the fast data type. Till now it is fine. Thanks. We will come with the next video with association mapping. Thanks for watching the video.